joined us in the morning, and he's ready with his presentation. And I would also take this opportunity to wish everyone a very healthy and happy World Water Day. You know, the United Nations General Assembly, I think in 1993, announced the World Water Day for the, awareness, because there are almost, more than 2 million people who have no access, 2 billion, sorry, people who have no access to the safe water. So that is the very poor status worldwide. And keeping that in view, the General Assembly of the United Nations in 1993 announced the 22 March as the World Water Day. And as you know, I can see that the theme of the 2022 is groundwater, making the invisible visible. And groundwater is invisible, but its impact is visible everywhere. Out of sight, under our feet, groundwater is a hidden treasure that enriches our lives. And our esteemed resource person will also, touch upon some of the facts. So, sir, our participants are from the various backgrounds, but from the bottom line, they are all, or most of them, having the forestry background. They are assistant professor and scientist C level or equivalent, coming from the agricultural as well as general universities, and some of them are from the non-governmental organizations as well. And dear participants, Dr. T. Basanta Singh Saab, he is presently ARS in the field of soil science of 2014 batch in ICR Research Complex for NEH region, spreading across Manipur, Central Imphal, West District. And he has completed his PhD from Bidhan Chandra Krishi Vishwavidyalaya, West Bengal. Dr. Singh has more than 20 research papers published in reputed national and international journals. He has also been credited for his books, manuals, abstracts in the national and international symposiums and seminars. He has more than 6 institutional funded ACRIP and externally funded projects as PI and co-PI. He also, has been recognized as a life member for various prestigious societies such as Indian Science Congress Association, Kolkata, Indian Association of Hill Farming, Indian Ecological Societies, and so on. Dr. Singh has been received, has received Young Scientist Award by the Society of Tropical Agriculture, New Delhi in 2018. He has guided MSc students in the Department of Agronomy, where he is currently working. So with this brief background, I would now request Dr. Singh to please take over and enrich and update our knowledge with his presentation on soil and water conservation technology for agricultural sustainability. Over to you, sir.
Thank you, Dr. Maheshwari, for the nice introduction. And I welcome all the participants and the organizers of this seminar.
21 days training program.
Training program, I think. So let me start my presentation because we have a limited time. So let me share my screen. Now, I think my slides are visible.
Yeah, great. Please.
Yeah. So I have been given the topic with soil and the water conservation technologies for sustainable agriculture. Is we are not much involved in the conservation of the these technologies development, and it is done by our engineers, that soil and the water conservation engineers. But I also involved in many development of many technologies and demonstration also. So I'll briefly discuss regarding all the technologies, but there are 2-3 technologies which I am very much involved in our center. So I'll elaborate in that regard. So I think all the participants, they are also very much having much knowledge regarding the soil and water conservation. So, sorry. As we know, soil is very much crucial, and water is like soil. Water is also very much indispensable for our life. Soil is the strongest natural job. Means whatever we put in the soil, it will be decomposed, and it will be neutralized by the whatever toxic materials. It will be neutralized by the soil with the gradual time. In agriculture practice, seeds should be planted by optimizing various uses of land and water resources for sustainable production, because soil resources are limited, and the water also day by day it is becoming limited. So we should retain maximum rainfall within the soil, provided safe disposing of the excess runoff from the slope, so that there should not be any loss of the soil. And the purpose of the soil and water conservation are to control runoff and thus prevent loss of soil by erosion or reduce soil compaction, to maintain or to improve the soil fertility, to conserve or drain the water, to harvest excess water. And just for the introduction, I am giving the classification. It is 3 types. One is physical measure, and here comes the mechanical and engineering technologies, and biological measures, also termed as vegetative measures, and agronomic measures, sometimes called as this is the best management practices. So application of soil and water conservation measures are often used in combination, especially mainly traditional soil and water conservation techniques, and increasingly considered as reasonable. Merely technical approaches are not often successful, especially without participation of the local farmers, forest managers, etc. Without them, whatever we give the approach, it will be futile. So participation is very much necessary. It has also been recognized that under modern circumstances, traditional measures alone may often be insufficient to conserve the vital soil and the water resources, and have to be supplemented by modern practices. So we are trying to develop in the north, especially in the northeastern region. It is mostly around 90% is covered with the hill and the slopes. So we are very much concerned regarding the conservation of soil, whatever we develop the technology. So there are lots of developed technologies. Everybody is already know, but whatever we are mentioning here, it is common. Some are common, very much common to the soil conservation as well as with the water conservation. For example, this bench terracing. This is also adopted for conservation of soil, and as well as it is also for the water conservation. So I will not go one by one, but whatever common is there, I'll go as a common. So bench terracing, it is our head office in Shillong. The bench terraces are suitable, but our office or our farm is sustained for more than 40-50 years because of making this bench terraces. Otherwise, we will be nowhere to cultivate the even doing the research also. Because of this bench terraces, we have our farm is sustained. So this is very much important. And normally it is done in the deep soils when the soil is more than 21 by 2 feet, and it can be laid in slopy lands ranging from 16.67 to 33% of the slopes where we can take up. So without means if the soil is not enough, having no enough depth, then making bench terracing is difficult. And I think I'll be giving the this write-up, and everybody will be getting the compendium. So I need not read each and everything. So whatever I am presenting here, I'll be giving to the organizers. So what kind of soil, bench terraces with 100-meter length, longitudinal grades in range of 0.2 to 8% are recommended for the alpine soil for high rainfall regions, etc. It is all written here. And let's go to other type of technologies. So here one very common thing in adopted here in Manipur and in the northeastern region is that this half moon terraces, they are very much suitable for the plantation of the citrus crops. Northeastern region is known for the citrus crops. This our Manipuri orange. One orange is GI tag recently, and one kachai lemon is there, very juicy lemon. It has been also GI tag. So nowadays, because of the prolonged cultivation and mismanagement practices in the slopes, it was declining. It is being declined for long, and we are trying to rejuvenate the citrus plants having the GI tag. So we have adopted this technology, and it was very successful. Till now, it is there. So this is the orange plants that we have rejuvenated. Almost the orchard was died, but with the use of this half moon terraces, we are able to sustain the production of the oranges, even though 1 or 2 year was somewhat diminished, but now it is in the full swing. So next is contour terracing with the stone bunding we can do. This is taken from the internet, but such type of huge investment are very much difficult for our resource poor northeastern region. And the zinc terracing is there. Zinc terraces is adopted in the land with 3 to 10% slope, and it is constructed in the medium to deep soil.
Hello.
It is also,
So I think we lost your voice. Yeah.
Yeah. Now is it okay?
Yeah. We lost you for a few, seconds, I guess, in between. Please carry on, sir.
Oh, this zinc terracing, it is very much useful in the 3 to 10% slope. Then contour grades and bunding. Contour bunding and the contour grades, they are having different purposes. The contour bunding are done to conserve both soil and the water, but for this graded bunds, sometimes people have the misunderstanding. They are similar, but graded bunds. Why graded bunds are done? Because graded bunds are done to release the excess water, especially to release the excess water in the contour bunding. All the bunds will be closed in the both sides, from the both sides, but in the graded bunds, one side will be open for release of the excess water, for safe release in the high rainfall areas. This is one example of contour bunding, and here in contour bunding, I think most of them are forestry background, so they might be knowing the A-frame. A-frame, one device is there. It is very easy to construct also with the wood or any bamboo. we can make a, then in the from the top of the that A, capital A, then one pendulum will be hanged and the middle will be marked. But whenever we go, we put this one, we try to put the pendulum in the middle of the A, then we will mark the foots of the A, then like that we'll go and it will make a contour with the same elevation. So we can make the contour bunding or terrace. So this is the gully development of gully plugging. These are done for checking the excess release of the water and the erosion of the soil. It is very much useful in the hilly areas. And one is staggered contour trenching is there. One is contour trench with staggered. Staggered here it is shown as the staggered. It is not continuous. This is also practiced to make the soil least disturbed. And for the contour trench continuous, it is done in the areas where disturbance of the soil is doesn't make much difficulty in the place. And this is catch pits where such pits are made and the water is deposited and it is infiltrated in the underground. And this is scooping. Small scooped pits are made to to harvest maximum rainwater. And here hedgerow planting, the vertical interval between the hedgerow may be taken as 1 to 1.5 meter. This is Tephrosia candida. It is tested in our farm, and it is very much. This is the picture of our one farm where we have planted, and it is very much useful, and it is effective in conserving the soil. And we have done a small research on this study on the cover cropping with the rice bean, soybean, groundnut, and the cowpea, where all are with the farmers practice. And here you see the control, how much soil has been lost, 29 tons, 29.8 tons per hectare. And per hectare minimum, the permissible soil loss of any place of India is around 11 tons per hectare. But you see 29 tons per hectare loss means there won't be any topsoil. So from this study, we can understand that cover cropping gives a very maximum protection, very good protection. And in this, this soybean gives gave the highest protection from the soil loss. And intercropping, we know intercropping we had it is very good for the conservation of the soil and the fertility development. Nowadays, natural farming also coming up to be taken up by the instructed by the NITI Aayog, and we are also trying to develop natural farming area with without intercropping. That also won't be possible. So the main this one for the intercropping is that we have one main crop, then we have more than one or two intercrops. So the intercrop should be not in one line, or it should be placed alternately, so that the fertility of the soil is not lost. And every year we have to shift the intercrops if possible. Then here in Manipur also we did intercropping with the banana, pineapple with banana, this carrot and maize in many small integrated farming systems. Then in the mainland India, wheat and vegetables are also taken out. The citrus and the vegetables are common in our place, and jatropha and sweet potato, etc. So according to the suitability of the place, we can take up the intercrops, but we should see the orientation of the farm so that the equal this light perception should be there. And this is in our farm. We have done intercropping with this tephrosia, and even fruit crops are there. Guava is there, and maize. And for intercrop in the slopes, we can intercrop with the vegetable species, with the fruit trees, and without making the terraces. This is without making the terraces, and this is we can make with the terraces also. But every terrace, after one or two terraces, we should plant the fruit trees so that the loss of the soil should be minimum. And with this, if we can, we have opportunity to develop the water harvesting this one area, then we can put the water harvesting structure, just like pond, small pond. We call it in the northeast, we call it jalkun. So vegetable species, fruits, it is the upper view, and here water harvesting structure we can put. So strip cropping also there. Strip cropping is a method of farming used when a slope is too steep or too long, or otherwise when one does not have an alternative method of preventing soil erosion. So we can take up in that case. This is the just picture of the strip cropping, and the last picture is adopted in our research farms. And the alley cropping is widely spaced cropping of the this field crop or any crop among the widely spaced trees, and the trees should be pruned properly so that the sunlight is available in the crops. So those are some of the pictures that we have in our farm also there. And the last picture is not from our farm, but the other three pictures are from our farm. Here, one thing, planting across the slope should be taken up for with every person. And the upper pictures, two pictures, you see they are planting the potato and this soybean groundnut along the slope. This is mainly practiced in the Meghalaya. Our headquarters is in Meghalaya, but still we are unable to check this type of cultivation in Meghalaya. So farmer has got a very strong mindset that this type of cropping is better for them. So we are trying hard to change their mindset. So whenever we take we plant the crop along the slopes, then all the soil will be eroded. This also intercropping with the perennial agroforestry. Thus, only first slide is first. This one is from our Manipur, but others are from downloaded. And this is in our KVK farm. This mulching with the this black polythene sheet. It is one of the demonstration in the pineapple. Pineapple is a perennial crop where this maintenance of wheat is very much difficult. So we put the trial for this polymulch. Then it is very good. It became very good result. And the ground cover, we can use the ground cover with the HDPE woven sheets or plastic bags. And this is the geotextile for soil conservation. I think every forestry person, they know much better for the conservation of the forest soils. And grass waterways, how we see, everybody might be seeing this in the internet also, and how a grass land is having a better water filtration than the bare lands. One thing, drawback for this grass waterway is that it will be means labor intensive. We have to maintain the grass waterway by cutting every year, and they have the chance for carrying the wheat seeds from the these waterways. And in South India, some farmers, they put these grasses nearby their drip irrigation system in the banana plantation system. They told that it maintains the proper this ecosystem for the banana growth and all. So I got the picture. And the vegetable barrier strip. And this is one study done by us in our farm, that with this device for making the soil loss estimation, the broom grass, we took the three broom grass. One is three grasses. One is broom grass, one is guinea grass, and the one is napier grass. In this, biomass development is highest for the guinea grass, and the soil carbon development is highest for the guinea grass, and the total soil loss is minimum for the guinea grass. So in the control you see it is 27.6 tons per hectare. This is beyond the permissible limit of the soil loss. So vegetative barriers are very good for the checking the soil erosion. So we can take up some of the grasses like Decanthium, Annulatum, Saccharum spontaneum, Botiocola, Persuta, this vetiver grass, and even cashew nut tree also. It is very good for conserving the soil and soil binding. Here, very common grass is this vetiver grass. This is very common in our northeast region, and we are planting this in the bunch of our farm. And most of the things we have discussed is for the both soil and the water conservation. They are also taken up, but here I'll come with especially for the water conservation measures. So, as a forestry backgrounds, I think everybody must be having the knowledge for the watershed, and your forests are the catchment area. Every forest, every land is included in one watershed area, and they are the catchment area for the watershed. So we should protect with the vegetative cover of the catchment areas, otherwise all the soils will be eroded. Here we can develop the community ponds. This is from the northeastern region. We have developed from the support of our institute. We have developed lots of community ponds where otherwise before land was barren, and nowadays, because of our support and the intervention, lots of farms are evergreen. And this is Jalkun. We call it Jalkun, and this is in our farm. It was barren for almost decades. Just recently only, I have lined this tank with this 1000 micron SDP seed, and from now onwards, I have established the sprinkler and the drip system in our farm. From the next year, after this monsoon, it will be all the water will be conserved in this pond, and under TSP tribal subplan, this the below these pictures, the underside tribal plant, I have installed about 40 jalkuns, such jalkuns in the farmer's field. So from this rainy season, monsoon onwards, we'll be able to see the results of these jalkuns. And we have already developed around 200, more than 200 jalkuns in our state. But because of the use of thin polythene sheet, this only just 250 micron, all are damaged within the 2 to 3 years of lifespan. So we have increased the thickness of this SDP sheet. It is 1000 micron. So I hope this will last for almost more than 10 years. So these are the jalkun. These black polythene ones are the recent ones, and this blue polythene ones, those are the previous one. Here you can see the 2009 also. This is demonstration from by our institute, and this one farmer, he has made a very big jalkun, and he is taking up the fisheries in the jalkun in the top of the hill also. And some of the farmers, they have developed very nice integrated farming system where the BC ratio of the farm is 1:8. You see in 1 rupee expenditure, he got the 8 rupees return. Then how much it will be? He is developing the fingerlings, this kiwi plantation. So they are benefited a lot. And these are some of the points we have from our support. We are trying to develop the integrated farm in this farmer's field. And jalkun, regarding the jalkun, they are aligned with the SDP or LDPE. Dimensions can be ranging from 3 meter into 2 meter into 1 meter depth, and up to 5 into 4 into 1.5. A dimension of 5 into 4 into depth is 1.5 meter is found to be very optimum for the our hilly region with the use of 250 micron. But we can increase the size if we can supply line with the pond with the 1000 micron, because of the leakage, frequent leakage of the this jalkun sheet, polythene sheet. The length and the breadth of the depth should be minimized to stick to 1.5 meter only depth for the 250 micron. But if you line with the 1000, then you can increase the volume of the water, this one. And when we study based on per unit water requirement, a jalkun having 30,000 liter stored water can support about 200 tomato plants in 250 square meter area, along with rearing of livestock during the lean period. Crop production like tomato, broccoli, cabbage, cauliflower, mustard, chili, they can be taken up during the Rabi season. And the livestock production and the fish production can also be done. Here, piggery is very common, and as per the standardized per unit water requirement of the pig farming, could support about 5 piglets for 200 days during dry spell, during October to April of the year. So jalkun is very much useful in our hilly.
Hello. Hello. Sir, I think we have lost you. Hello. Are you there, sir? Dear participants, he lost the internet connection, so he's just trying to, reconnect himself. Please bear with us. He is trying to, for the reconnection, but it seems that it may take a longer time for him to reconnect. If it takes too long, then we will have to end this session today, and we will have to wait. I think he gets connected. Hello.
Doctor?
Yeah, we lost you, I think.
Yeah, I lost mobile. Let me connect the system. Just
your voice is breaking. We can't hear you properly.
Okay. The problem is there.
We can't hear you. Your voice is breaking actually. Are you with us? Hello. Again, I think there's some serious network glitch. Hello.
Hello, sir. Can you hear me?
Yeah, but your voice is breaking. There are actually two sign-ups simultaneously, is showing in the system.
No, I have left on one. I think now it is already gone. Still showing?
Yeah, it's fine now. Yeah, could you please, hurry up and share our screen, because we have our next resource person lined up from 11:30. Yeah.
Okay. Am I visible? Audible and visible?
It's visible. I would suggest if the network interruption is there, you may switch off the video so that the audio and the display quality would be boosted up.
Yeah. I'm trying.
Yeah.
Okay, now.
Yeah, please. Yeah, carry on.
With the size of about 10 into 30 into depth 10 meter, we can construct this storage structure with 70,000. And new technology for the harvesting of the water is dew harvesting. Here, where in the African region and Israel and all, they are trying to harvest the dew for the cultivation of the crop. And this is the percolation tank. Percolation tanks are used for recharging the groundwater from the leftover rain. And this is the seepage are used for the where the infiltration of the soil is high. And this is the recharge well. It is used in the soil irrigation and for the household purposes. And this is the small channels and small rivers. And this is bamboo spur stone lining. Here in Manipur, we planted maize crops, and this zero tillage, zero mustard we cultivate in about 500 hectares. Furrows and furrows to irrigate, and if we go inside the field, then all the soil will be so we never try to go inside the field once it is irrigated. And this is one of the field of farmers field of our TSP village. And here in northeastern region, we develop technology that is in the second bed. Here we dig the soil about 3 to 5 meters. Then whatever the excess will put the this and in the bed we plant the vegetables. The sunken bed we plant the rice and the other aquatic crops. This is the diagram of the race and the sunken bed development. And presently, now I am in charge of developing this race and the sunken bed demonstration farm in 1 acre of land in our campus. So the work is going on. This is yesterday's photos only. So we are trying to develop one demonstration farm. And micro irrigation system. Everybody knows the drip irrigation and the sprinkler, etc. And the multiple use of water. We should use of multiple at multiple levels. And these are the Tanka traditional water harvesting structure in Rajasthan. This is very much useful for recharging the ground, and even they use as a well. And this is PAR traditional rainwater structure harvesting structure in the Rajasthan. And nowadays for irrigation purpose, reports are coming for the after testing of the soil. Every time installed in the before irrigation, it will be soil thermometers and moisture meters are installed in the field, and based on the reading, they will irrigate themselves. So with this, I finished my presentation. So let's discuss together if any.
Yeah, thank you very much, sir. Of course, the network glitches and the signal interruption are inevitable, completely beyond our things. But we could we could grasp the major things what you have compiled in your presentation. That was really nice. Thank you so much. And you as mentioned in your initial slides of your talk that you will be sending the resource and course material for the particular talk, so that we will further share with our participants as well. And I'm also taking this liberty to uh, share your email ID in the chat box, so that the participants could contact you directly. So dear participants, if you have any question, you may please ask Dr. Singh directly. So it appears, sir, because there was so much signal interruption and gaps in between the presentation. But I'm sure the participants have got your email ID, and I think if you like, you may also share your mobile number so that you can reach you directly over the phone. With that, I would now request my colleague, Dr. Mohammad Nasir, to kindly deliver a vote of thanks to you. Dr. Nasir, please.
Thank you. Good morning, Dr. Basanta. Thank you very much for your such a detailed and illustrative presentation. And I must say that it was a complete presentation on soil and water conservation. You have touched upon all the aspects of the soil and water conservation subjects. So you brief up the subject from the very basic application to the advancement in the subject. So I must say that all the participants would have thoroughly enjoyed the subject, and they must have learned from it a lot. So with this word, sir, I would on behalf of the organizing committee and my own behalf, I thank you, sir. Thank you very much. Over to you.
Thank you, Dr. Nasir. Thank you.
Maheshwari.
And even Arbind Gupta was here for
Yeah, thank you very much, sir.
Thank you everyone for your patience and having an interaction. Thank you organizers.
Take care, sir. Bye. Dear participants, we apologize for the signal interruption, and you would understand that such thing happen in the virtual things, and that is the new normal is all about. Anyway, so we will take a 10 minutes break, and as our resource person has already joined, and he would deliver his talk on the forest resources and their conservation in Northeast India. We look forward to his lecture, and that session would start from 11:30. So we will take a short break of